Hello, everyone. I hope I'm live now. So, a very good evening to all. I'll wait for a few seconds so that everyone will join. Meanwhile, those who are watching me live, please try to give me the confirmation that whether I am clearly audible or not. And then maybe after a few minutes of waiting, I'll try to start the session. I hope already you guys have seen from the thumbnail and the heading itself that today's objective is to talk about dynamic programming. A lot many students have requested me personally on my Insta and on my LinkedIn chat that please try to take this session live. And even I can see the comment in this live also by Anuj. He's saying that मैम ग्राफ का सेशन लाओ आप तो अपकमिंग सेशन ग्राफ का भी ले आएंगे डोंट वरी पर आज के सेशन में अब हम डीपी के बारे में डिस्कस करेंगे क्योंकि एक काफ़ी इंटरेस्टिंग कॉन्सेप्ट है और बहुत सारे स्टूडेंट्स को इस कॉन्सेप्ट को समझने में काफ़ी प्रॉब्लम रहता है कुछ मिसकंसेप्शंस भी हैं है ना कि काफ़ी डिफिकल्ट होता है डायनामिक प्रोग्रामिंग बट ऐसा नहीं होता डीपी इज़ वेरी इजी द ओनली प्री रिक्विजिट ऑफ दिस सेशन इज कि आपको रिकर्जन आना चाहिए I hope that whosoever is watching me live and whosoever will watch after this session also in a recorded pace. So let me give you a disclaimer that this session you will be able to enjoy only if you know the concept of recursion. So if there is anyone who is not aware about the concept of recursion, he or she might face trouble in understanding the concept. Okay. So recursion का मैंने बहुत सारे वीडियोस डीएस से यूजिंग पाइथन वाली प्लेलिस्ट में बनाया हुआ है so I hope that you all are aware about the concept of recursion. So today we will just focus on the DP concept and we'll try to get a clarity over this concept so that the hype of DP is very difficult. We will be able to resolve that. So before moving ahead, can you guys give me the confirmation that am I clearly audible and visible to everyone? Is my voice is perfectly clear to all? Can you guys give me the confirmation? Umar is saying hello. Hello, Umar. Uh, as I said, Anuj is saying, ma'am, graph ka session, lao up. So definitely in the upcoming sessions, I'll try to take up the graph as well. But could you guys give me the confirmation before we will proceed? Am I clearly audible? Am I clearly visible? Everything is so far so good. Uh, so Jay Shankar is saying yes, audible. Thank you so much for the confirmation. Uh, Perfect. So now what I will do is meanwhile, we will do the setup. Those who are joining, people are joining, still joining. I can see that many people joined just now. So what I can do is, meanwhile, others are also joining. If you want to, tell your friends also, please tell. Session will start within few seconds. Meanwhile, I am trying to share my screen and do let me know in the chat window whether my screen is visible or not. Okay, and then maybe we will start our today's session. Perfect. Is my screen is visible to everyone? दिख रहा है ना? Screen दिख रहा है ना? I think yeah, it is visible. I have opened on my other screen. दिख रहा है. Okay, perfect. आपकी पसंद 2.0. Nice name. Good evening. A very good evening. Okay. Can you share relevance of DP for data science use cases? Okay, perfect. We'll see. Definitely we will see. चलें आगे या थोड़ा सा और वेट करें अच्छा मीनवाइल इफ यू हैव एनी क्वेश्चंस यू कैन आस्क एक दो मिनट और वेट करते हैं विल ट्राई टू वेट फॉर वन और 2 minutes more and then maybe I'll start my session any questions you have anyone let's wait for few seconds more and then we will start sometimes students say that you just start very early so let me wait for few more seconds and then we will start. Any questions? No questions? Shall we start then? Perfect. Let's start the session then. If you don't have any questions, तो सबसे पहले those who are for the very first time joining me live, so basically let's try to first of all understand कि DP होता क्या है. I am pre-assuming that there are so many students who are dealing with DP from the very scratch. So let's try to understand first of all what is DP, what is dynamic programming, and at what point of time we should go for this DP approach. ठीक है, इसको समझने की कोशिश करते हैं, फिर स्टेप बाय स्टेप आगे चलेंगे, क्वेश्चंस को कैसे करना होता है उसका अप्रोच समझेंगे. So first of all, what is dynamic programming? Dynamic programming है क्या? So I would say that this is not a unique concept, or this is not a very new concept in DSA. This is something which you will observe is a enhanced recursion. Is a enhanced recursion. अब recursion क्या होता है? This is what I am pre-assuming कि आपको पता है. But let me give you a brief idea that whenever we are talking about recursion, it simply indicates that you are trying to call function within itself. For example, let me give you, instead of giving the definition, one simple example which I usually take is finding of a factorial of a number. So let's say you want to find out the 5 factorial, so you will say it will be 5 into 4 factorial, right? So until you reach to a base case condition, you will keep on repeating this task. So how basically you will do that? So whenever we're talking about recursion, we always take care of two things. As I always say, कि पहली चीज होती है base case condition. The first thing is the base case condition. For example, in this case, my base case condition will be that the 0 factorial and the 1 factorial is 1. So I will say if the value of n is less than equal to 1, just return the answer as 1. Just return me the answer as 1. In which case I am saying? In the factorial case. Because I know that whenever I try to evaluate the value of a factor of n, I know that when the value of n is 0 or the value of n is 1, in both of the answers, the answer will be 1. Now, second thing is the recursive function call. Second thing is the recursive function call. Right? Recursive function call. This says that if, let's say this is not the scenario, if the value of n is bigger than 1, in that case, what will you return? And you will say that I'll return the value of n into fact of n minus 1. So what is recursion here? How will you identify that this is a recursive code? The simple thing which I always say is this function is there, right? And I'm using this function inside this function definition also. That is the literal meaning of recursion which we usually say, right? Now, when I'm saying DP is an enhanced recursion problem statement. Whenever you will try to solve a problem, you will use enhanced recursion concept. What is the meaning of enhanced here? I'll try to explain to you with the help of one simple example. But before that, I think this much part is pretty much clear to everyone. Now, there is a very famous problem which we say is Fibonacci series. I think I have talked about this problem a lot in a recursive module as well when I created the video of recursion in my DSA using Python playlist. If you will observe, Fibonacci series says that if you will try to write the numbers, anyone knows what is Fibonacci series? Let's say 0, 1, 2, 3, 4, 5, 6, and so on. Let's say these numbers we have. Okay. So here we will be having 0, 1, 2, 3, 4, 5, 6, 7. What does the Fibonacci series number says? Anyone who is having an idea? It says when the value of n is 0, answer will be 0. When the value of n is 1, answer will be 1. But when the value of n is 2, the answer will be the addition of the previous two numbers. So it will be 1. When the value of n is 3, previous two numbers, it will be 2. When the value of n is 4, it will be 3. When the value of n is 5, it will be 5. What I'm doing here, I am doing the addition of previous two elements as mentioned by Vinay. Right? As mentioned by Vinay. It's the addition of a previous two elements. I'll not take now any other logistics apart from the session which we are doing. At the end of the session, I'll do 5 to 10 minutes Q&A depending upon how many questions are pending, and then I'll take your questions apart from the session which you are trying to talk about. Okay, then 5 plus 3 is 8, 8 plus 5 is 13. So this is how the Fibonacci series all about says. So if I'll say to you that can you write a recursive code for the same, you will say that recursive code will be fib of n. Inside that you will say what is the base case condition. As I said, first task is to talk about the base case condition. You will say that the base case condition will be equals to when the value of n is less than equal to 1. In that case, let's say if the value of n is either 0 or it will be equals to 1, in that case you are saying that simply return the answer as n. Can I say n? If that is not the case, then we need to apply a recursive function call, right? We need to apply a recursive function call. And in that, what we will say? We will say return. What is the function name? Function name is fib of n, right? So we will say return fib of n minus 1 plus fib of n minus 2. Can I say everyone? Does everyone agrees with me on this point? Can you guys give me the confirmation yes or no in the chat window so that I can get to know that whether you are following me or not? I'm going very slow, very fast, sorry, here in this part, because I believe you already knew this thing, right? In a Fibonacci series, we are trying to add the previous two numbers, considering the base case condition is when the value of n is 0 or 1, we are returning the value as n, means when the value is 0, it will be 0, when the value is 1, it will be 1, right? So simple. Now the question is that researchers, when initially designed this recursion way of solving a problem, they faced some trouble. What's the kind of a trouble and why this DP came into picture? I want to answer that question. See, whenever you're trying to study any new topic, please, the way should be any new topic, be it any domain, be it DSA, be it data science, be it in any other domain, the way should be, first of all, you should know what is that topic all about. Then you should know why we need that. That's where you will get the motivation, right? If I'll not talk about why, what's the issue that DP is trying to solve to us, then obviously you will not feel motivated to learn and to go 1 hour of session, right? I have to give you the motivation that why we should study this particular part, why it is important. So that's what I'm trying to convey here. So we are trying to discuss now. So first question we have discussed what? This is something where I have said it's an enhanced recursion. So the prerequisite of this session is that you should know recursion. I have given you one example. The second thing I'm trying to convey here is why. Why DP? Why it is required? So that's where we are just as of now focusing on. So here, if you will observe, we have designed a recursive code of a Fibonacci series. Here, if I'll ask you, what is the recurrence relation of this Fibonacci series? Or in other words, if I'll ask you, what is the time complexity of above recursive code? Can anyone tell me the answer? What is the time complexity of this recursive code? Anyone who can give me the answer with the proper reason? Please don't make any guesses. I want a proper reason for that. I think those who already have watched my playlist of DSA using Python, they definitely know the answer. And let's see who will be able to give me the correct answer with the proper justification. I'm saying, what do you think is the time complexity of this Fibonacci series code which I have mentioned just now? Anyone who will be able to give me the answer? Let's see. There are so many students who are watching me live. Anyone? Can I expect any answer? I'm expecting at least one or two will give me the correct answer in my audience. Umar is saying big O of n. It's wrong. Any other answer? Can I get some correct answer? Big O of n is wrong. Okay, I'll wait for a few more seconds, then I'll start talking about. Let's see if we will be able to get some correct answer also by someone. No. Okay, let me talk about then. So first of all, whenever we will be talking about a time complexity part of any recursive code, I have talked several number of times that you need to create a recurrence relation for that. Now, what is the recurrence relation of this particular code? Let's say you will be having a time complexity T of n. Okay, it's a base case condition. Vinay is saying it's constant. No, not at all. Please try to understand. Please pay more attention now. Here, if you will observe, the very first thing is uh, now I got the correct answer by Prashant. It's exponential 2 ki power n. It's correct. This is the correct answer which is given by Prashant. Very good, Prashant. So here, if you will observe how it is exponential, at least I got one answer correct. I was expecting that at least one student can give me the correct answer. One or two I was expecting. Good. So here, if you will observe why it is exponential, now I'm giving the reason. Please try to pay attention here. Whenever we are talking about any recursive code, whenever we are dealing with any recursive code, first of all, we need to create a recurrence relation of that. So here, if you will see fib of n, let's say the complexity will be T of n. Now we have two components in recursion. First is the base case condition. Now in base case condition, we just have if condition where we are directly returning the answer, right? So it's a constant task. But we have recursive function call, which is nothing but T of n minus 1 plus T of n minus 2. Why T is repeating? Because that's where you're repeating your function call. Fib and fib is repeating internally, right? Can you see that? So your recurrence relation, if someone will ask you in an interview, you can say the recurrence relation will be T of n, which is equals to T of n minus 1 plus T of n minus 2 plus C. Now, if there is anyone who is not able to get an idea that how we will be able to solve any recurrence relation, how we will be able to solve any recurrence relation, let me just show you one interesting thing here. Please, these are the very important things. If you don't know, try to watch this recording. Can you see this particular video? The art of solving recurrence relation techniques for success. Can you see this video? This video is available in DSA using Python playlist. If you will go and check it out, this video, you will be able to get an idea that, you know, what are the things that you have to take care of? How many different types of recurrence relation do we have? Here I have explained all the methods of solving a recurrence relation: substitution, recursive tree, master's theorem. So here, if you will observe this recurrence relation, you will be able to solve via something called as recursive tree method. Recursive tree method. And with the help of that method, you will be able to get that complexity as big O of 2 ki power n. Big O of 2 ki power n. And it's an exponential time complexity. It's an exponential time complexity task. Now, why it is happening? Let's try to move deep dive into this. Why it is happening? What I will do is, I'll try to show you one simple example, and with the help of which I think you will be able to get the idea what is the major issue in this normal recursive code. Let's say I want to evaluate what is fib of 7. I want to get what is fib of 7. So you know that fib of 7 we will be able to get, according to the above code, we will be able to get what is the value of fib of, first of all, we need to evaluate what is the value of fib of 6. Plus, we need to evaluate what is the value of fib of 5. Right? What is the value of fib of 5? Can I say, everyone? Then to evaluate fib of 6, you will go again to evaluate what is the value of fib of 5, what is the value of fib of 4. To evaluate fib of 5, you will say that I will have to evaluate what is fib of 4, what is fib of 3. Because in a Fibonacci series, as we have discussed, it's a addition of a previous two numbers. So we need to evaluate that. So fib of 4 will be evaluated by fib of 3 plus fib of 2. Fib of 3 you will evaluate by fib of 2 plus fib of 1. Fib of 2 you will be able to evaluate when you will be able to get the value of fib of 1 plus fib of 0. That's how the same thing you will follow in this part also. The same thing that you have followed here, because this is also fib of 3, right? Similarly, this fib of 2, same thing you will write here. It means that you will try to get more sub problems here, here also, and here also. I'm not doing it, but I'm just trying to convey you the important point that what's the issue in a normal recursive code? What's the problem in this recursive code which you will write? The problem is, will you be able to observe some problem here? If you will observe here, I have already evaluated the fib of 3. I have to do the recomputation again on the right side. I have to do the recomputation again on the right side to calculate what is the value of fib of 3. Similarly, once you have done the evaluation of fib of 4, you are doing the recomputation again on the right side of fib of 4. Similarly, once you have done the evaluation of fib of 5, you are doing again on the right side. This problem is something which we called as overlapping subproblem. This problem is something which we called as overlapping subproblem. Will you be able to understand what the problem I'm talking about here? I'm saying that what you're trying to do is you are trying to recompute the same function call in a recursive tree. Can I say so? क्या आप सेम फंक्शन कॉल को रिकम्प्यूट कर रहे हैं यहाँ पे या नहीं? अरे भैया, हमने फिब ऑफ 4 को इवेल्युएट कर लिया लेफ्ट साइड में, फिब ऑफ 4 को दोबारा इवेल्युएट करना है राइट साइड में, फिब ऑफ 5 को कर लिया, दोबारा करना है राइट साइड में. तो यहाँ पे प्रॉब्लम क्या हो रहा है कि बार बार रिकम्प्यूटेशन हो रहा है इस रिकर्सिव कोड में. दैट्स द मेजर इशू. I hope now you will be able to understand. Now what will happen is, let's say if you will take the value of n is very big, let's say I'll assume that your value of n is 50 or it will be 100. What will happen? There will be more the recursive tree will be very big. There will be more recomputations which will happen. Can I say? There will be more recomputations which will happen. And that's the major issue. And that's why you will observe in many problems of recursion, you are facing an issue called as TLE. I don't know how many of you have observed this. Time limit exceeded. Time limit exceeded. Why? Because internally there is so much recomputations which are happening in the recursion that you are getting an error of TLE. And that's where, to avoid this TLE issue, we came across something called as a concept of dynamic programming. That's where dynamic programming is the hero. तो dynamic programming बोलता है कि मैं इस इशू को रिजॉल्व करेगा, जो बार बार रिकम्प्यूटेशंस हो रहे हैं उसको ट्राई करूंगा अवॉइड करने का. समझ में आता है? Is this part is clear to everyone? What I'm trying to convey here, is this clear? Why DP is important? In order to avoid that problem of overlapping subproblems in a normal recursive code, that recomputation which is happening in a normal recursive code, to avoid that TLE issue, we are approaching towards DP, dynamic programming. So if in future someone will ask you why DP is required at all, will you be able to answer this question? Yes or no? Can I get the confirmation? Yes, everyone? Okay. अब नेक्स्ट तीसरे क्वेश्चन पे चलते हैं. हमें कैसे पता चलेगा कि ये डीपी का क्वेश्चन है? हाउ विल वी गेट टू नो? This is the question which is very frequently asked by so many students, that how will we get to know that this is a DP problem? है ना? या फिर in other words, if I'll just flip the question, given a problem statement, maybe on lead code, maybe we are solving any real-time project in data science, or maybe in web development, anywhere, be it anywhere. See, DSA is a optimization part. As I always say, DSA is important for every domain. So it's very important to understand the concepts of DSA, because Then only you will be able to optimize your code. So the question is, be it any real-time project or be it for the interview perspective where we will be able to get a lead code based questions, how will we get to know that, okay, this is a kind of a thing where we will apply a DP kind of approach, right? How will we get to know? The first clue that you will get to know is, if in any given question, if in any given question, you are dividing your problem into two sub problems like this, like this, like this, and getting that overlapping sub problem kind of a thing. There are high chances when you're dividing your problem into two sub problems, you are getting that overlapping sub problem kind of a issue. That's where the first clue is DP must be used. Okay. If you will observe here also, in this Fibonacci series question, I am dividing my problem into two sub problems and somehow overlapping sub problem issue is there. And that's where I told you that DP is the rescue. That's the first hint that a question will be giving, will be providing to you, or any circumstances given to you in a real-time project. The second hint is, if let's say in a given question, if let's say in a given question, they are saying to you that you need to find out a maxima or maximum or minimum of something. Let's say maximum subarray is a problem that is very famous, which is usually solved by Kadane's algorithm. It's an application of a DP. Or something minima you need to find out within a given array. Means your problem is composed of some optimization task or to find out some optimal solutions. Your problem is composed of something to find out an optimal solution. That's where again you will be able to get an idea that DP is something which I can use here. So in a nutshell, there are two hints with the help of which you will be able to realize that I can use a DP somehow here. At least you can give a try. The first hint is that if any problem is divided into two sub problems and you are seeing an overlapping sub problem kind of an issue, recomputation is happening. Very strong hint, DP can be used. Second thing is, if in a given problem, the interviewer is saying that you need to find out a maximum of this array or minimum of something, very high chances that DP can be used. Either DP or, as I always say, there is another approach is greedy approach. So out of these two approaches, one approach can be used. So these are the two variety of problems where the concept of dynamic programming is used. Is this part is clear to everyone? So in any of these two circumstances, you will always go for DP. Now, when I'm saying the first option, that one problem is divided into two sub problems and overlapping sub problem is there, you can ask me a question. I don't know why you didn't ask until so far, that is the same problem will happen in every recursive code? No. The answer is simple no. Straight no. Why is that so? If you remember, when I started my session, I have given you the example of a factorial of a given problem. In this problem, if you will observe, if I'll ask you to create a subtree or tree, let's say you want to evaluate what is the value of factor of 5, what will happen? The recursive tree will look like 5 into factor of 4. Then you will go and you will say 4 into factor of 3. Then further you will say 3 into factor of 2. Then further you will say 2 into factor of 1. And finally you will be able to get the answer as 1 here, right? So basically here, if you will observe, I am not dividing my problem into two sub problems, or you are not seeing any overlapping sub problem here, right? That's why in this case, recursion is amazing approach. And that's why if you will observe, this code is giving you complexity of big O of n. But below code was giving you the complexity of exponential, which is very high. If you have seen my video of time complexity classes, this exponential class is at the very end, nearby end. So what I'm trying to say here is that in this particular case, DP is a solution which we need to discuss, which we need to see. Is this part is clear? Shall we move ahead now to discuss the DP approaches that we have? Now, until so far, we have discussed from the starting of the session What is dynamic programming? We have seen that it's an enhanced recursion. We have seen why DP is required, because in some of the recursive codes, there is a problem of overlapping subproblem, means there is a recomputation of a function call, which leads to a very high time complexity like exponential. And that's why DP approach came into picture. Third thing which we have observed is how we get to know that in any given question this is a dynamic programming problem, and we can solve it via DP approaches. I have talked about two major hints. First hint is if your problem is being divided into two sub problems and there is a problem of overlapping sub problem, that's the first hint. The second hint is that if in any given problem they're talking about a maximum finding or a minimum finding in an array, or be it any data structure, then also you can apply this DP approaches. Is this part is clear? What, why, and how? These three things are clear to everyone? Yes or no? Can I get the confirmation from everyone? I hope everything so far is pretty much clear to everyone. It's like a story which is coming up. Yes or no? Shall we move ahead? If I'll just solve single problem also na, in very detail in today's session, you will be easily able to solve so many problems, because if you will get to know the flow, how we should think about solving any given problem, then DP is very easy for you. You will try, you will enjoy, afterwards learning the concepts. Right? Shall we move ahead? So my target is not to cover up 7-8 problems. No, I want to cover up maybe single problem, but that problem should be discussed in a very detail from very scratch, so that even a person who is not from this background will also able to understand what this DP is all about. Okay? Perfect. Let's move ahead now. So how now let's try to understand what is this DP approach says. Whenever I'm talking about dynamic programming approach, we usually talk about two approaches. First approach is something which we call as memoization approach. And that's how the flow should go. In any given problem, first of all, you should think about recursive approach. We already have a thought about that with respect to Fibonacci series. Now, the second important thing is, okay, DP is required. We get to know why is that so. We already sorted in that part. Now we know that the very first approach in DP is memoization. Now the question is, how can I apply this memoization approach, or what this memoization approach for the very first thing is all about? Okay, it says very simple thing, and it's very intuitive as well. It says, what is the problem in the recursive approach? The problem is that my code is doing the recomputation, and that's why it leads to TLE sort of error, right? So memoization says, I'll try to use the recursive concept only, but it's an enhanced recursion. What is the meaning of that? I think that's where we started our discussion of DP, enhanced recursion. It says that what I will do now, why not I'll try to save the function call values or the results in some data structure. And that came out to be a very brilliant idea at that point of time. If we will be able to store the values of every function call, then what will happen? If same function call is coming up in a recursive tree, I will first of all check in my data structure. If it's already there, I'll fetch up the value. If it's not there, I'll compute it via recursion. So simple, so straightforward. And that's where the complexity goes down from exponential to linear. So what I'm saying, please try to listen it out very carefully. You will really appreciate this concept. So what they say is, or what researchers have developed at that point of time, that, why not to create some data structure? Maybe let's take hash table. Okay, hash table by the name of, let's say, memo. What we will do is, what is hash table? Hash table is something which will be having a key value pair. I hope everyone knows this part. Key and a value pair, right? This is key and this is value. Now what will happen is, here we will be having fib of, let's say we want to evaluate fib of 7. Fib of 7 will call fib of 6. Now you all know, in a hash table, the key always contains a unique value. Unique things are there. So this key, this memo hash table will contain only unique function calls, which will not be already present inside my hash table. So fib of 7 is there, fib of 6 is there, fib of 5 is there, let's say fib of 4 is there, fib of 3 is there, then fib of 2 is there, and fib of 1 is there. So what I have done is, I have tried to store all the function calls as a key inside my hash table. Now, when the computation happened, fib of 1 will give me the answer as 1, fib of 2 give me the answer as 1, fib of 3 give me the answer as 2, fib of 4 give me the answer as 3, fib of 5 give me the answer as 5. What happened is, I have stored all the function calls inside the hash table. Now let's say if on the right side of a recursive tree, fib of 5 is being evaluated, I will not re-evaluate it again. I'll check it out. Is my fib of 5 value is present inside my hash table? If yes, then why there is a need to do the computation? And if I'm not doing, that's where I'm saving the time in my code. That's where the optimization happened. Then fib of 6 will be 8, fib of 7 will be 13. So what is happening is, if you are having the value of n as 7, you are trying to do the computation of only 7 unique function calls. But in the above scenario, if you will observe, that's not what the thing was. In the above scenario, we are doing too many computations because too many recomputations are happening, too many recursive calls were there. In this also, I am taking an approach of a recursion, but here I am avoiding that particular recomputation part using the memoization approach. Memoization means you are trying to create a separate data structure called as memo, and there you're trying to store the values. So if there is a repeated of some value, you will try to fetch the data directly. Is this part is clear to everyone? And because you are trying to compute only the unique function calls, the value of n is 7 function calls you're trying to solve. That's why the complexity will become big O of n. So now you will observe, you will be only just by this logic which you will be able to get, you will be able to decrease down your complexity from exponential to directly linear time complexity task. And that's the beauty behind DP. Is this part is clear to everyone? Yes or no? Is this clear? Can I get some confirmation? So I'll try to show you now one practical example of whatever things I have just now talked about. From the last 38 minutes, I'm just speaking up and I'm trying to convey the logical things, but that logic will not make sense if I'll not show you any practical. So we'll try to take one practical example here. This climbing stairs example. Now this climbing stairs is also an example of Fibonacci series itself. If you know Fibonacci series, you will be easily able to solve climbing stairs problem. If you will observe, it's very frequently asked in a lot many companies. I hope you can see a list of companies. This is very, very, very important problem. Usually people prefer to ask this problem a lot in the interviews. Let's try to understand first of all the problem statement. Then we will try to solve it down via the above two approaches which we have talked about. What this is saying? It is saying that you are climbing a staircase. Okay. It takes n steps to reach to the top. Okay. Each time you can either climb 1 step or 2 steps. So we are having a staircase, n steps is there. Now at a time, a user can either climb single step or he or she can climb 2 steps. The question is, in how many distinct ways can you climb to the top? Fine. Let's say if you will be having n as 2. So there are 2 ways. How 2 ways are possible? Either a person can go one step at a time, or a person can go directly to the 2 steps. Similarly, if the value of n is 3, there are 3 ways. How 3 ways? Either a person can go one step at a time, or a person can go firstly one step followed by two steps, or vice versa, two steps followed by one step. So what I'm trying to say here is, in this problem, they are saying, in the climbing stairs problem, what they are saying is, I hope you will be able to understand what they are saying. They are saying a person can either go one step at a time, or he can move two step at a time, right? Now let's say if the value of n is 2, let's talk about when the value of n is 1. Can you tell me what is the answer? How many number of ways are there so that a person can move to the top if we will be having only single stairs? Can I say we will be having only one way? Can I say, everyone? What is that one way? Only if I'll go to the one single step. That's the only way which I have, right? When the value of n is 2, in that scenario, if I'll ask you how many number of ways do we have? Obviously, it will be two ways. How two ways? Either a person can go one step plus then further one step, because there are two steps, two way, n value is 2, or directly he can go to the two steps, right? If the value of n is 3, there are, I am saying, three ways. How it is possible? Either a person can go one step, or a person can go one followed by two steps, or a person can go two followed by one step. Yes or no, everyone? Yes or no? Because it is given, a constraint is given that a person can either go one step or he can go two step. Makes sense? Similarly, when the value of n is 4, can you give me the answer? How many number of steps will be there? When the value of n is 4, how many number of ways will be there? Anyone who can give me the correct answer? When the value of n is 4, how many number of ways will be there? Can you think of? Let's see who will be able to give me the correct answer. Again, I am expecting at least one correct answer. Not many though. Think over it. It's a logical problem, right? What I am saying is a person can go either a single step or a two step at a time. How many total number of ways are there to reach the top if we will be having only 4 stairs? Okay, you are saying to me either a person can go one, bilkul theek baat hai, or a person can go, Vinay is saying 2, that's also fine. Another way can be a person can go 1, that's also perfect. Any other way? These three are fine. Any other way? Can I say a person can go 2, 1, 1, or a person can go 1, 1, 2? So can I say it will be 5 ways? Can I say it will be 5 ways? Yes or no, everyone? It will be 1. Second way is this. Third way is this. Fourth way is this. Fifth way is this. Is this correct? Yes or no? Now, here if you will try to observe, let me create one array here. Let's see what is happening. Let's see what is happening. Be very observant in the session. If you will pay 100% attention, then only you will be able to gain out of this. Now I'm trying to draw something here and let me know what is happening, how the results are looking up. You guys only give me the answer. I'll not tell you the answer. Let's say it is 0, or maybe let's say it is 1, it is 2, it is 3, it is 4, it is 5, it is 6, it is 7, it is 8, it is 9. Let's say when the value of n is 1, I'm getting the answer as 1. One way. So n is the number of stairs, answer is number of ways. Okay? When the value of n is 2, my answer is coming out to be 2. You can refer to the above PDF. I have written the answer as well. When the value of n is 3, I'm getting the answer as 3. In the above case, you can verify. When the value of n is 4, I'm getting the answer as 5. Can you tell me any observation which you will be able to observe by these answers? Anyone who can tell me? Can you see something? Just try to relate these things in a Fibonacci series just now that we have discussed the concept. You will be able to get an idea. If you're not sleeping and listening very patiently everything, you will be able to get that. I'm 100% sure. It's kind of a Fibonacci. How? If you will observe, Let's say if we'll say the base case condition will be, the base case condition will be when the value of n is 1 or when the value of n is 2. In that case, what we will do? We will say return n. We will say return n. Right? But if that is not the case, in else case, what we can do? Let's say my function name is number of ways. Number of ways of n. So what we will return? We will return number of ways of n minus 1 plus number of ways of n minus 2. Can I say everyone yes or no? Is it the same recurrence relation that we have done in the previous part as well? Can I say everyone? That's why if you will observe, 3 is the answer of addition of previous two numbers. 5 is the answer of addition of previous two numbers. Next answer will be, I can mention 8. Next answer will be 13. Next answer will be 21. Next will be 34. Next will be 55. Next will be 89 and so on. Can I say everyone? So let's try to now do it using a normal code, using a recursion. Okay? Let's try to do it using a recursion. Simple. We got the logic, we'll try to implement it. Okay? What we can do, because we are doing via a normal recursive approach, so what we will do? We will say, what is the base case condition? First thing is the base case condition. And the base case condition will be, if the value of n is equal to 1, or if the value of n is equal to 2, in that case, return me the value as n itself. If that is not the case, just return me. What is the second step of any recursion code? Second step is the recursive function call. So what you will do, you will return same function you will call climb stairs. Inside that you will mention n minus 1 plus climb stairs n minus 2. Can I say this is what we have studied just now, the logic part? If I just run this, you can see this is accepted, right? If I just submit this, now focus here, completely focus here. What is happening? What is happening? It is showing me TLE, time limit exceeded. And you can see 31 out of 45 test cases have been passed. It means that when the value of n is small, it is working perfectly fine. But when they increase the value of n as 45, the problem started. Because that's where they are getting a very huge number of recursive function calls. Recursive tree is very big, recomputations are very high, and your code will not able to cater up that thing. Because there you can see in the constraint, so many people usually ask me, what's the point of having a constraints? Today you will get to know. If you will observe here, they have mentioned they will take a value from 1 to 45. So at 45, this test case is not passing. But now I will show you another amazing thing here. Let me open again this platform. And let me go to the problems part again. And let me search here one problem by the name of Fibonacci. Fibonacci number. Okay. This is the same problem that we have discussed, right? Okay. What we can do here is, let me just first of all reset this thing. Here, if you will observe, we have discussed this part. What is Fibonacci number? If you will try to apply the same approach, this code will work. The same code will work here. Why? Because here, if you will observe, the value of n they're picking up very small. It is not until 45. So if I just apply the same code of Fibonacci here, if I'll say if the value of n is 0, or if the value of n is 1, return the answer as n. In other part, I am saying return fib of n minus 1 plus fib of n minus 2. If I'll just run this, accepted. Amazing. If I'll just submit this, submitted. So now you will, if after the session, maybe you will come to me that, if I'll just not show you this particular thing on the live, you can come and write in the comment that I have tried the Fibonacci number question. You told me that recursive code will not work, but this is working. See, listen my point very carefully. DP is helpful when you're working in a very huge amount of a data. Here, when the value of n is very small, your normal recursive code is also working fine. But it's not like that the complexity is very small. No. Here also it will be 2 power n. But that 2 power n will become very big number when your value of n is very high. You can see the example. When it is going towards 45, it is not accepted. But when it is until 30, it is giving the result perfectly fine. I hope now you will be able to get a better idea that what is the major issue in the recursive approach and how basically now we can avoid that. That's the second point. Make sense? Shall we move ahead to the second part of code, where now we need to see that how we can optimize this code via the concept of memoization. Memoization, which I am saying it's a enhanced recursion only. It's an enhanced recursion only, but it's a very first approach of dynamic programming. Shall I move ahead? Can I get some confirmation from you guys? Yes or no? सब कुछ समझ में आ रहा है? Is everything is clear? Can I expect yes from everyone? If there is something which is not clear, can you write in the comment section or maybe in the chat window? Comment section, those who will watch after the session in the recorded pace, you can write in the comment section. But because you are joining me live, those who are joining me live, they can write in the chat window. समझ में आ रहा है? Perfect. तो अब करते हैं मेमोइजेशन से कैसे होगा. Let's see how we can do our memoization. Okay. So what we can do, again, it's a recursion only. So very first thing that we have to tap on is the base case condition. It's the base case condition, right? So base case condition is that if the value of n is equal to 1, or if the value of n is equal to 2, simply return the answer as n. Perfectly fine. Now, what I will do here is, I'll try to create one data structure, which is public, static. Let me create a map where my key is of integer type and my value is also of integer type. Okay. Let's take it as memo. Vinay, I'll answer your question. Just let me implement this, then I'll take your question. It's a good question. Now, new hash map. So I have created one data structure, which is a memo. It's a hash table we will try to create. Now, what we will do, before we will make a recursive function call, we will check always, is my keys already present inside my hash table or not? If memo.contains key, let's say if it is already available, that value of n, what I will do, I'll directly return, what I'll return? The value. I'll not do the recomputation again. And that's where, if you will observe, optimization happened. That's where we will be able to avoid the recomputations which was happening in the previous code. Can you see that? Now, once this is done, if let's say this is not the scenario, then what is the scenario? Obviously, you have to make a second thing, which is a recursive function call, right? Recursive function call, because the key is already not available in your hash table. So what you will do, you will say int number of ways is equals to, you will call the function climb stairs again with the value n minus 1 plus climb stairs again with value n minus 2, right? Climb stairs again with value n minus 2. Make sense? After that, what you will do? Before returning anything, you will feed this value inside the hash table so that now the computation is done. But in future, I don't want to do the computation. I will just feed this value, right? N value is number of ways. Once this is done, you will return what? Number of ways which you will be able to get. Done. Now let's run this code again. Accepted. Perfect. Try to submit this. Working perfectly fine. Can you see that? Now it is not giving me any sort of issue which was given to me previously, because now we have applied an optimized approach of DP to avoid the recomputations. Make sense? Can you see what's the beauty behind the dynamic programming? Now Vinay is asking me one very amazing question, that okay, you told us that in a Fibonacci number the range is very less, so normal recursive code is working fine. Here it is not less, so we need to talk about DP. But how do we get to know if n is huge, right? So see, that is something which, if you are not working with a specific platform just like lead code, you will not able to get an idea. But so this 30 is, or maybe 45 is a threshold value. This threshold you will not able to get if you will do manually your code, until or unless you will not tap on the numbers. Let's say you are doing on your VS code. If you will tap on the numbers, you will see that on 20 it is working fine, on 30 normal recursive code is working fine, on 40 maybe it is not working fine. That's where you will get to know that your code is not working fine, and you will be able to check it out. But when you're moving towards a lead code based platform, so what you usually do, your flow should be that you will always start with the recursive code. As I already said this point also, that first thing should be your way of doing a code is, first of all, the first step is you will write a recursive code. If the test cases are hidden also, if they are having a very small value of n, and if they have not provided a proper constraint also, you will write a normal recursive code and check it out whether the things are working fine, test cases are passing. If you're working in terms of interview perspective, you're talking, the only motive in the very first round for them is that you will be able to pass the test cases. So that sounds well, it's completely fine, you can just go to the next question. If you're talking in a technical round, you should ask from the interviewer very clearly that this is the way we have, but in this way we will be able to not deal with the very big values of n, and that's where we will move towards the DP approaches. If you are having a hidden test cases, if they're passing, completely fine. If they're not passing, then you should go for the very first thing, which is a memoization in DP. Because memoization is very easy to understand, because you already know the recursive code, you can easily able to code a memoized approach. The only thing is that you have to do is you need to create a separate data structure, and with the help of that you will be able to store the values. Very simple approach. And the last one is something that we have is tabulation, which we will discuss now. But before that, now, as I told you, in this memoization approach that we have just now discussed, that we have just now discussed, complexity is big of n, as I already have discussed. The time complexity is big of n. If I'll ask from you, what is the space complexity? What is the space complexity? So here, if you will observe, yes, we have used an extra space. A stack space is there, which is because of recursion, plus because we have used an external data structure of hash table, it will be big of n. Can I say, everyone? So yes, on the stake of taking extra space, we will be able to optimize our time, which is from exponential to linear, which is a good deal, right? The last way of solving is via tabulation, which I want to discuss here. Now, tabulation is the third thing which you should think of. Tabulation approach in DP doesn't use the idea of recursion. There will be no recursion which is involved in tabulation. And that's the beauty behind tabulation approach. So, if you will observe, if the value of n is too much high, in memoization, a recursive tree is created. And that's where you are using a stack space as well. That's a very slow process as comparable to tabulation. So if someone will ask you which one is a better one, in terms of complexity, both are same. But if you really want to, compare between memoization and tabulation, tabulation is something which is far, far better because of not using any recursion at all as comparable to memoization. The only reason is that it is bit faster as comparable to that when the value of n is very, very high. Okay. What this tabulation says, it says that why there is a need to use recursion at all. What you can do is take simple array now, and what you can do is initialize the values. Let's say 0. Let's say you will be having a value 1, 2, 3, 4, 5, 6, 7, 8, and 9. Initialize the values, right? Let's say this is the array name climbing stairs CS. What you can do is take an array of size n plus 1 because you are starting from 0, right? Here I have started from 1, but by default we will start from 0. And what you can do is you can initialize your values, no? It will be 1 and it will be 2 in the array. Now you know that the next number will be the addition of the previous numbers. So what you can do? You can do very simple thing. What is that? You can apply one for loop which will start from I equal to 3, will go until the value of n. And what you are doing? You are trying to fill your array with the value of what is the value present at before 2 points, I minus 1 and I minus 2. And this is how what you will do is you will be able to fill up all the values that you have in the given array. So what will happen? You will be able to get a value like 3, then 5, then 8, then 13, then 21, then 34, and then 55, right? And finally, what you will do is, so let's say you will be having a function name climb stairs, and inside that you will be having a value of n. What you will do is finally you will return the last value which you want to really find out. You will be able to get the answer. So here if you will observe, I am not using any sort of recursion. I am just doing a single for loop. That's why the time will become big of n. So what I am saying is, let me try to convey you via the code part as well. Let me try to reset it again, and we'll try to apply something called as a tabulation approach here. Tabulation approach, where I am saying that there is no recursion which is being involved. That is the beauty. And this is also a part of a dynamic programming approach. Okay. So what I am saying here is, what I will do is, I'll say, if let's say the value of n is 1, in that case, the answer is very easy. You can return the answer as 1. Not an issue. If that is not the case, what you can do, you can take a new array by the name of CS, climbing stairs, and you can define that array with the size n plus 1 because you are starting from 0 and you want to go until n. What you can do is simply define your value of CS1 as 1 because you know the answer will be 1 in that case. CS2 as 2, you know the answer as 2 in that scenario. And what you can do is you can apply simple for loop which will start from value of I equal to 3, go until n, will do I plus plus. And what we will do? We will just simply evaluate what is the value of CS of I. CS of I minus 1 plus CS of I minus 2. That's it. So here if you will see, this is my function name. Have I used this function name inside the definition? Nowhere I have used. Means I'm not using any sort of recursion here. Finally, what I will do, I'll return the CS of n. Task is done. If you just try to run it, accepted. If you just try to submit it, accepted. So this is the last approach, which is another amazing approach, which doesn't even require the recursion. Here, if you will observe, time complexity is something which will coming out to be big of n, and the space is something, because we're using an extra data structure called as array, it will be also linear. Is this clear? So Jaishankar is saying, just one doubt, how we are able to access the hash table, because hash table is created within function. Okay, so you're talking about previous code which I have removed. So I have not created the hash table inside the function. If you remember, I will share the code. I have created that hash function inside the class. Okay, so it will be accessible. Fine. I have not created inside the function definition, I have created outside. I think you didn't saw that. I'll share the code. Maybe you can see it. And then via the simple function calls that we have with the for the hash tables, we will be able to get that value, right? Got it? Perfect. Any other question anyone is having? So this is the last point which I want to convey. I think it's being 1 hour. Uh, it's too much as of now. I'll not extend this session now. So basically, the major objective here is to talk about, to give you a brief idea about DP, why it is required, and how basically we can solve any problem. I think I have done that as well. So from the very starting, we have started with what is DP. Then we have covered up why DP is required. Then we have covered up how we get to know that any problem is a DP problem. Then I have taken a very good example of a climbing stairs problem on lead code, which is very frequently asked in a lot of interviews, where I have shown you a normal recursive code, practically what is the issue behind that. Then I have solved practically memoization approach, and I hope that with the help of practical implementation, you will be able to get a better idea that how that is better, far better than the normal recursive code. And then at the very end, we have talked about tabulation approach, and I told you that if someone will try to give you a comparison, which one is better and which one is slower, right? Is this session, I hope you will be able to get a clarity now what and how DP is all about. In the upcoming sessions, I'll try to conduct more live, where we will try to move forward towards solving more interview problems. Today we have just talked about only single problem of climbing stairs and Fibonacci series. You can say two problems we have talked about. In the upcoming session, I'll talk about few more problems like knapsack, Kadane's algorithm, which is very frequently asked. uh, but let me know whether you will be able to understand the today's session, because today's session is the prerequisite to go for the further advanced sessions of DP. If you don't know the today's session itself, or if you're not able to get the clarity of today's session, then obviously whatever advanced concepts I'll cover up in the upcoming live, you will not able to understand. Those who are watching me live also, that's the major prerequisite. Please try to watch the recordings before coming to the next live. If you want to join me live, then only you need to take care that you will completely watch these recordings and then only come to the next live. Yes, how is the session? Will you be able to understand? Can I get some confirmation from everyone so that we can wrap up the today's session? Is this clear or everything is messed up now? समझ में आया? Is the point is clear what I'm trying to convey here from the last 1 hour? So in the initial session, in the initial part, when I started the session, Jaishankar asked me applications of dynamic programming in data science. So there are so many applications, Jaishankar, that we have. I don't know whether you have worked in speech recognition part or not. The algorithms that we are working in internally there, again, all are worked on the basis of DP itself. So what is the difference between greedy approaches and DP is DP always try to make sure that they will be able to see the possible test cases, all the possible use cases. In the upcoming session, maybe I'll take it up again, where I'll show you the differences between the greedy approaches that we have versus the DP approaches. And the major difference which I can talk about in a nutshell is that they will be able to look out all the possible use cases. So whenever in any situation, in any scenario, in any domain, you want to look for all the possible use cases, that's where DP came into picture. So in speech recognition, in NLP domain, there are so many applications and algorithms that we have, which is completely done or developed on basis of DP. Okay. So maybe I'll try to conduct a separate session in data science per se. That's where maybe I'll talk about this question again in a lot more depth. Here, maybe the audience might not be from data science, so they will not able to understand the algorithms if I'll talk about any of them with respect to NLP or speech recognition per se. So that's of no use. So let's take it until so far. And if you want to go in a very lot more depth, whatever domains I have talked about, you can search it on the Google, or maybe I'll try to conduct a separate live for the data science audience where we can talk about a lot more with respect to this question. Okay. Vinay is saying everything is okay about the session, bit confused, but I'll be okay. It will be okay once revised, but why don't you smile? Because when I'm teaching, I'm in that zone of teaching. Now I am smiling, see? So that's the reason. Nothing more than that. I'm not a very serious person. Don't worry. Any other question apart from this? I'm just looking up above questions. Mm, pum 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 pum. No, 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 no. Uh, I think I have taken all the questions as I can see from my first side. Yeah, I have taken all the questions. Thank you so much, everyone, for joining in. I hope you find this session insightful. I'll attach all the session notes as well as the code files in the comment of this video. Please do share this video. Please do hit like button and try to, I am trying to reach out to more audience. Still, many people don't are not aware about this channel. I really want you guys to help me out in this particular thing as well. Right, if you are finding it insightful, then only please do share it with everyone, and I'll see you all very soon in the upcoming live, where we will try to solve few more advanced problems of DP, as it's the very first session. So I have taken a very easy level problem. In the upcoming session, we will take it from easy to medium level problems, and we'll try to understand more on top of these concepts. But I believe now the fear of uh, that dynamic programming is not there after listening from past 1 hour. Thank you so much for joining in and listening me from past 1 hour. I know I speak a lot, but you guys are listening to me. That's super amazing. Acha, Vinay is saying lead code or hacker rank for product based companies. Lead code is much preferable, I believe so, because nowadays lead code is getting a very good problems, and even if you will go to the interviews also, they are asking the questions which are very similar to lead code platform. So I will prefer lead code as comparable to hacker rank. Hacker rank is not something which I will prefer nowadays, right? Thank you, Jay Shankar, for joining in. Okay. Thank you so much, everyone. I think I have answered the questions. Bye bye. Take care. Good night. See ya. I'll see you all very soon in the upcoming live.